You got your first rock?
Yes, it's a quartzite.
An active quarry just east of this is the second most important aquifer on that island. And that's because of all the cracks. So you can't get water out of it, which is pretty amazing. You wouldn't believe it. It was actually discovered by accident, because when they drilled water wells and they
Okay, we're looking at lower Cambrian quartzites, and they're really tight, but they're intensely fractured, so they gave up looking for water because they were so cemented. But he was just telling, our guide was telling us a story about how a water driller hit a whole series of fractures, and they were artesian pressured, and so they can get water out of it, they just have to follow the fractures.
Scolitas, Diplocarian, pretty shallow water. Part of it will also be cross-bedded. A lot of this stuff is what you see is storm events, but yeah, it's pretty dusty. We need some rain.
There's a lot going on.
I don't know, it looks a little dangerous.
Over right? Let's do it right now. Special kind of dolomite. It has a very special composition, but I'm not a hard rocker.
Just looking at the contact. It cuts across.
Oh, that's nice. I think it looks
That is true.
The deeply buried fault tectonic lower Paleozoic. If you, this is the section how it was up in north to some of these faulted fault blocks. In Scania you can envision that the surface is the, so we are right now here where we have the yellow is the sandstone that we just visited down at Schrylle. Then we moved a little bit further into the black one, which is the alum shale. And you can envision that the Løvestad and the other shales were just drilled down from the surface and then just 1 kilometer down. So this is the reason why we can go to these exposures and why we can still drill like a few kilometers away. They will be at 1 kilometer of depth. So looking at this peak in gamma ray, which is one of the most distinct peaks at all in the alum shale, and we can correlate that, if you go on the other one, we can correlate that peak around all things. So it is still something that we think about a lot, because you might have heard, if you are familiar with the Cambrian stratigraphy, I don't know whether any of you are, just below this event, just 2 or 3 meters up here, we can actually point to that point. So this is a global spice event, and that's also one of them that we have all the trilobites as you will see, but the trilobites that you can find here, most of them.
I will go with the same thing. We can go with it.
Oh yeah.
like this. Yeah. So they are.
So you can see all the things. So we are down at 510 million years ago. Let's see if
Aqueles que vais pagando aos poucos.
Very, very different. One silk frame. And when you're a fossil collector like me, you will go for the limestone because the trilobites, they are not flattened, they are in full relief. So they are much nicer inside the limestone. But you need a big hammer. And as I said, the section here, when you go into the basin and you approach, when you go into shallow water, there when the sea level drops, then the storm wave base.
does anybody have a red t-shirt on? No.
competition.
No, there's nothing going on. They will just be.
Well, you've got a red.
Yeah. That's what I was.
Double the chances.
Yes. Well, the first stop today, that was normal oxygen conditions in this epicontinental sea. In the Ordovician, we move northward.
That's electrician.
We are probably having glaciation in Gondwana. So the limestone belt characteristic of shallower water here in the Ordovician moved downslope. There was nearly no clastic influx from Baltica. The main influx came from the collision belts out in the Iapetus west of Norway. So that was a western source. But this limestone here, you can see bedded. These beds, some of these beds.
With shale, and here at this side of the Comstead limestone is only 4 meters thick at the drill site here. But the same photography we can see. And we then went into the casing point of the Trojan shale that was up above the Trojan shale that was in here. And now we're in and I think that you have the rock types that it's a gas exploration. Was this in which you can see in the gamma ray that it jumps a little bit up here before it really there's a scale change zone, and it's a typical secondary target, and it's has a little bit lower organic matter here, around 4% at maximum, but on average it will be 2 or 3. And thickness wise, these spikes, which is the most organic rich, that would be like on a 10 meter scale. So this rock is good. It has actually less clay because of the changing depositional environment. There is much more siltstone or silted material. Perhaps a little less in porosity, whereas in this rock type, 4% of organic matter will correlate around 4 to 5%. That's due to this change in the fabric. We have a more silty.
Oil geologists know what a GSSP is. It's a global stratotype point. It's one of them places where you put in a golden spike and say this is the boundary. And this particular boundary here is the base of the upper Ordovician. So the global upper Ordovician base is located in this scrofy section here. Because in Scania we have these black shales and they contain graptolites, and there's a very complete graptolite succession despite being condensed. So Scania here was a good place to do it. The downside is that putting a GSSP in shales, you need graptolites to identify it. So even though we here in Baltica have the global lower boundary of the upper Ordovician, we cannot identify it when we go into the limestone in shallower water. But then you have to use conodonts and sometimes trilobites, but it's an approximate boundary. Out here it's a very precise boundary.
Sorry, did you find any?
This is a limestone which has been, it's a biplastic limestone. It's not a reef structure. What you look at is probably drop a more clean limestone. But that is just a bump on the road to filling up this basin. If you want to see really nice reef limestone from this period, you should go to the island of Scotland. Mega UITs, they are chemical precipitation on the seafloor around warm water. So we have a very high carbonate production here. The brown one, that one.
I don't know which is the
Upper Ordovician Silurian limestones here. And the story is that the climate has changed, so we've come up from the Cambrian, and as the plates have moved, this is in the Upper Silurian, it's now a warm environment, so a lot of rapid growth in the carbonates, and so there's a lot of fossils in here, oncoids, trilobites, and we have to break it open. We don't have a whole lot of hammers, so I'm gonna borrow somebody else's hammer.
Find some. There are actually some nice ones. Here's a nice one.
Je te dis que si, Michel. Ça aussi, ça c'est des fossiles.
How about here?
If you want it.
what is it to point out?
Yeah, there's some include there, this one, this guy. There's all over the place. There was like some pretty nice mussels over there. Yeah.
Not so many mosquitoes right now. What a pity. Yeah. No, here. Trolleybugs are not that common, but yes, they are here.
Now the paleontologist is starting.